Now we will consider answers of question numbers 27, 28 and 31. So question number 27 is the standard deviation of marks of a set of 1000 college students was 11 and the mean mark was 78. Assuming the distribution to be normal, find the highest mark of lowest 10, the interquartile range, the limits within which middle 90% will lie. So we shall come to answer of this question. See, in this question, we have to answer three things. We are given the marks of 1000 students mean and standard deviation. Mean is given as 78, standard deviation as 11. Also assume that, also we are given that these marks follow normal distribution. So we take X as a letter representing the mark of a student, that's a variable, and this X follows therefore normal 78 and 11 square. The first case is to find the highest mark of lowest 10. We have arranged the marks of 1000 students in decreasing order. Therefore, the greatest mark appears in the top. Then next mark just below that and goes like that, and the lowest mark appears corresponding to the 1000. So since the highest mark of lowest 10 is required, we look upon the downside of this arrangement. Here, there is an entry corresponding to 990, that is x dash. See, below this x dash, we have again 10 more marks. And this x dash is considered to be the greatest mark of the lowest 10. The question is to find out this x dash. But note that below this x dash, again there are 10 marks. So based upon this property, we can formulate a probability equation. That is, X is the mark of a student. Below X dash, there are 10 more marks, and therefore probability of X less than or equal to X dash will be 10 by 1000. That's equal to 0.01. So this equation is formulated based upon the position of X dash. X dash is positioned such that below X dash there are 10 marks, and X dash is considered to be the greatest mark of the lowest 10. Now to refer the values from standard normal tables, we transform the normal to standard normal using the standardization principle. That is x minus 78 by 11 is equal to x dash minus 78 by 11. It is 0.01. So the left side is standard normal random variable. So set less than or equal to x dash minus 78 by 11, which is 0.01. So we put the lower and upper limits. So minus infinity is the default limit of variable set. So minus infinity less than z less than or equal to x dash minus 78 by 11, 0.01. So this is the figure corresponding to the interval and also the probability 0.01. So the interval is starting from minus infinity and reaches at 7 x dash minus 78 by 11, and the area occupied is 0.01. Therefore, definitely this x dash minus 78 by 11 should appear this in the negative side. So to have a reference of this x dash minus 78 by 11, we consider an interval starting from 0, that is 0 to x dash minus 78 by 11 is 0.49. That is, we have the references from tables starting from 0 limit. I shall open the page of tables of standard normal distribution. So here all the values are tabulated for intervals with starting point 0. The probabilities or areas are entered here, and all are corresponding to intervals with starting point 0. That's why we consider again an interval starting with 0. So 0 to x dash minus 78 by 11 is 0.49. The 0.49 is obtained by subtracting 0.01 from the entire right of area, that is 0.5. So for getting an x dash minus 78 by 11, we consider an equivalent sector in the other side, the right side, and we get the table value from that tables of standard normal distribution corresponding to this area 0.49. So for the 0.49, we can see in the entries that is 0.4901. 0.4901 corresponding to this entry, the value is 2.33. That's from the margin 2.33. So 2.33 is the value of this x dash minus 78 by 11, and also we put a minus sign since that is appearing in negative side. So x dash minus 78 by 11 is equal to minus 2.33. So x dash is 11 into minus 2.33 plus 78, which is 52.37. So the highest mark of lowest 10 is 52.37, and we note that above this, below this 52.37, 10 students marks will appear. That is the case 1 answer. The second case is to find the interquartile range. See, the interquartile range means the difference between the two quartiles. That is interquartile range, the range between the two quartiles. So which are the two quartiles? Q3 and Q1. So that's why we write interquartile range as Q3 minus Q1. So what are Q1 and Q3? Q1 and Q3 are the first and third quartiles. Q1 is referred as probability of x less than or equal to Q1 is 0.25. Q3 is defined as x greater than or equal to Q3 is 0.25. Actually, Q1 and Q3 are two positional averages. The positions are such that below this Q1, 25% of 25% of observations will appear, and above this Q3, 25% observations will appear, or below Q3 75% observations will appear. That is their quartiles. So this property is used to formulate equations for finding this Q1 and Q3. So since 25% of observations appear below Q1, the probability of a value of this observation less than or equal to Q1 is 0.25. That is the property possessed by Q1. That is P of x less than or equal to Q1 is 0.25. Now from hereafter we can transform this x variable to standard normal random variable, that is x minus 78 by 11 less than or equal to q1 minus 78 by 11 0.25, and this from tables of standard normal distribution we can obtain the side of the value of q1 minus 78 by 11. We can look upon the figure. In this figure it means that probability of x z, I'm missing skipping 2 or 3 steps here. It is p of z less than or equal to q1 minus 78 by 11. So minus infinity to q1 minus 78 by 11 equals 0.25. So reference of this left tail is not available in the table. So we might consider a equivalent sector in the right side, and that right side sector has a lower limit q1 minus 78 by 11 and upper limit infinity. So here 0.25, you can see in the table 0.25 is appearing corresponding to 0.25 among the entries. You can see that 0.25 is appearing between 0.67 and 0.68, that is 2486 and 2517. The exact value 0.25 is not in the table, so we take the nearest value 0.2486 corresponding to 0.2486. In the margin you can see it's a coincidence of the row 0.6 and the column 0.07, that is 0.67. So this is x dash minus, now q1 minus 78 by 11 is q1 minus 78 by 11 is minus 0.67. So when you solve that equation it is 70.63, that is 11 into minus 0.67 plus 78, that is 70.63. Now x greater than equal to q3 is equal to 0.25. That is according to the property of third quartile. So again do the same similar steps, that is standardization and reference of table. Here we have the sector in the right side, that is the right tail area. So q3 minus 78 by 11 to infinity area will be 0.25. So again we consider the area from 0 to q3 minus 78 by 11. So that also will be 0.25, that is 0.5 minus the right tail area 0.25. So the area from 0 to q3 minus 78 by 11 will be also 0.25, and corresponding to 0.25 we found in the earlier case it has 0.67. So but it is in the positive side, so this is q3 minus 78 by 11 is equal to 0.67. So we have the third quartile as 11 into 0.67 plus 78, that is 85.37. So we also note that both Q3 and Q1 are equidistant from that middle value, that is 78. From 78, when you subtract this 11 into minus 0.67, we get 70.63. From 78, when you add 11 into 0.67, we get 85.37. So definitely Q1 and Q3 are equidistant from Q2, and actually Q2 is the median, or Q2 is equal to median is equal to mean, and that is the most middle value, that is 85.37. Therefore the interquartile range is their difference, 85.37 minus 70.63, which is 11.64. So when you come to the third case, that is to get the middle 90 percentage, we can have the most middle value. The most middle value will be median. That is what we found in the case of quartiles also. So the two quartiles Q1 and Q3 occupy middle 50 percentage. That is 25 percentage left and 25 percentage right. That is middle 50 percentage. Here we have to get 90 percentage middle. So we depend upon the most middle value mu, that is the mean or median. From that mean or median, we backward take 45 percentage, and forward we take 45 percentage. That is here given in the figure. A to mu 45 percentage, mu to B 45 percentage, so that the middle sector starting from A to B has a total area 90 percentage. So we have two equations: A less than or equal to X less than or equal to mu probability equal to A mu less than or equal to X less than or equal to B probability is equal to 0.45. And we take the first equation and standardize that equation using the standardization principle. So it is A minus 78 by 11 less than or equal to X minus 78 by 11 less than or equal to 78 minus 78 by 11. Mu is 78. So it is A minus 78 by 11 less than or equal to Z less than or equal to 0 is equal to 0.45. So you can consider an equivalence. This definitely this A minus 78 by 11 will be in the negative side. So we can take an equivalent point in the right side, the image of A minus 78 by 11 in the right side, and from tables we can look upon the value or area 0.45 will be attained. You can see that area 0.45 will be attained at 1.64 or 1.65. You can take approximately as 1.64. That is the coincidence of the row 1.6 and the column 0.04. That is 0.4495. So it is then A minus 78 by 11 is equal to minus 1.64. So A is 11 into minus 1.64 plus 78, that is 59.96. Likewise, we can solve B also by considering the other side interval, that is P of mu less than or equal to X less than or equal to B is equal to 0.45, doing the standardization and refer the tables. So we get B minus 78 by 11, 1.64, which is supposed to be the image of A, because A and B must be equidistant from the most middle value. So that must be 1.64, the exact image of minus 1.64. Again solving, we can see B is equal to 96.04, that is 11 into 1.64 plus 78. And therefore, this A is 78 minus 11 into 1.64 and B is 78 plus 11 into 1.64. So thus A, B occupy the middle 90 percentage observations. Now we have next question 28. In a normal distribution, 20% observations are greater than 70 and 10% observations lie between 60 and 70. Find the mean and standard deviation. Again, we make use of these two informations to formulate certain equations. We take x, the observation, x representing the observation. Now, since 20% observations are greater than 70, we have the equation P of x greater than or equal to 70 is 0.20. So the next line shows that 60 and 70, between 60 and 70 observations, 10 percentage will appear. Therefore, if you club both greater than 70 and 60 and 70, we have greater than 60. Therefore, we have the equation probability of x greater than or equal to 60. This is not 60. It's a correction. This is not 30, it is 60. That is P of, I shall do the correction right now. What I mean is this point, the second equation, that is P of x greater than or equal to 30. This is not 30, this must be 60. Now x greater than or equal to 60 is equal to 0.30. So you take the first equation, P of x minus mu by sigma greater than or equal to 70 minus mu by sigma 0.20. Now z greater than 70 minus mu by sigma is equal to 0.20. Writing the reverse order, that is starting from the lower limit to the upper limit infinity. So this section area is 0.20. Naturally the other side means starting from 0. The range starting from 0 to 70 minus mu by sigma has area 0.30. So have a look upon the tables of standard normal distribution to get this. Sorry, that table is closed. I will open the table now. Yes, 0.30 is appearing, corresponding to the table value 0.84, 0.84. That is the 0.2995 is the coincidence of the row zero point 0.8 and the column 0.04. So we have that 0.84 and it is in the positive side. So 0.84, 70 minus mu by sigma is equal to 0.84, 70 minus mu is equal to 0.84 sigma. It's the first equation. The second equation, as we are starting with this value 60 here, even though we have written as an error, as a mistake, 30 here, the answer is in 60. So P of x less than or equal to 60 is 0.30. The 0.30 is by combining the 20% and 10% and combining the intervals x greater than or equal to 60 is equal to 0.30. Now again doing the standardization, so we have that 60 minus mu by sigma less than or equal to z less than infinity is equal to 0.30. In this figure we have the tail area 0.30 and the starting 0 starting interval to 0 starting interval has the area 0.20. That is area from 0 to 60 minus mu by sigma is 0.20. So in tables the area 0.20 is attained at 0.52. Therefore, the 0.60 minus mu by sigma is equal to 0.52. 60 minus mu is 0.52. So solving those two equations, we get mu as sigma as 31.25. That is subtracting 2 from 1. 2 from 1. So we get 10 equals 0.32 sigma. So sigma is 31.25. So mu will be, again substituting the sigma value in one of the equations, mu will be 43.75. That's the answer of question number 28. So we come to the next number 31. In 31, in a normal distribution, 31 percentage of items are under 45 and 8 percentage are over 64. Find the mean and standard deviation of the normal distribution. Again, this is a case of backward reference from normal distribution tables, standard normal distribution tables, and also solving the two equations. So first of all, we can formulate the two equations since we are given 31 percentage are under 45. P of x less than or equal to 45 is 0.31. So P of x minus mu by sigma less than or equal to 45 minus mu by sigma, which is 0.31. So we have given the sector having an area 0.31 here in the left tail, that is minus infinity to 45 minus mu by sigma is equal to 0.31. So for reference we consider the area starting with the lower limit 0. So 0 to 45 minus mu by sigma area will be 0.19. So in tables that 0.19 attaining point is 0.19. So this is that 0.19, that is 0.50, 0.1915. So you take it as approximately 0.19 and the value corresponding to z in the margin will be 0.50. So this is 0.50, so that it is negative. So 45 minus mu by sigma is 0. Minus 0.5. So we consider the second equation, greater than 64, 8 percentage, 8 percentage are over 64. So x greater than equal to 64 is 0.08, x minus b by sigma, 64 minus b by sigma 0.08. So that is shown in the figure, that is the right tail area 0.08. Therefore that is 0 starting. Here I put a 0 and this is that infinity, and therefore 0 to 0.0 to 64 minus mu by sigma is 0.42. That is the area. So in the table we see where that 0.42 is appearing. You can see that 0.42, it is very close to 0.42, 0.4192, that is 1.4. So when we come to that equation, it is 64 minus mu by sigma 1.4. Also note that that 0.64 minus mu by sigma is appearing in the right side. That's why positive sign 1.4. So it's solving again, 64 minus mu is equal to 1.4 sigma. So you consider the equation 2 minus 1. So we have sigma equal to 10. So substituting sigma equal to 10 in one of the equations, we get mu equal to 50. That's about answer of question number 31. Thank you.